Good morning, my dear students. Today we are going to discuss Fourier series. Very interesting topic. So before we are going to proceed the preliminaries, so you should give the like symbol and subscribe this video. Okay, thank you. Let's move to the topic. Fourier series. Let f of x be defined in the interval c less than x less than c plus 2 pi with period 2 pi and satisfy the following Dirichlet conditions. Then f of x can be written as, so f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity a n cos nx plus summation n is equal to 1 to infinity bn sin nx. So see, this is very important for fix, isn't it? So here what are the things very important? So this is the series. This particular series is called a Fourier series. So it has three parts: a naught by 2 plus summation an cos nx plus summation bn sin nx. So these are the three important terms which is in this particular Fourier series. So here a naught, a and b n are called Fourier constants, isn't it? And also we have to concentrate on the interval. See the very second line, the interval, I mean x lies in between c comma c plus 2 pi with period 2 pi. So these are the things very important. And also, before we are going to apply the Fourier series, the function f of x should satisfy the following conditions. These particular conditions are called Dirichlet conditions. Number one, f of x is single valued. The f of x, the function f of x should be single valued function. And second thing, f of x has finite number of discontinuous in a particular period of 2 pi. So within this limit, within this interval, it has finite number of discontinuous, isn't it? And then third condition, f of x has a finite number of maxima and minima in a given period. So the given curve maybe go up and down like that, isn't it? So the upside, positive side may be maxima, go downside it may be minimum. So it should be finite, isn't it? So in the particular period 0 comma 2 pi. And third one, next one, integral c to c plus 2 pi mod f of x dx is convergent, isn't it? So these are the four important conditions are called a Dirichlet condition. If that particular f of x satisfies the four conditions, it can be applied or we can proceed to find Fourier series. So my dear students, before we are going to substitute or proceed Fourier series, please or kindly check the given f of x satisfy the conditions. The particular conditions are called Dirichlet conditions, isn't it? So remember the conditions as well as the definition of Fourier series. Okay, then next one, for a naught, where a naught is equal to c, this is very important, a naught equal to 1 by pi integral from c to c plus 2 phi f of x dx, and an is equal to 1 by pi from c to c plus 2 pi f of x cos nx dx, and bn is equal to 1 by pi from c to c plus 2 pi f of x sin nx into dx. Case 1 or type 1, if c is equal to 0, in that interval becomes, so we know the interval from x lies in between c to c plus 2 pi. If you put c equal to 0, the interval becomes 0 comma 2 pi, isn't it? So in that interval, a naught becomes 1 by pi from 0 to 2 pi f of x dx. An is equal to 1 by pi from 0 to 2 pi f of x cos nx dx. An, sorry, so it is not an, it is bn. Last one, it is bn, isn't it? So bn is equal to 1 by pi 0 to 2 pi f of x sin nx dx. So please remember, this is the formula. These are the Fourier constant a naught, a n, b n in the particular interval 0 comma 2 pi. Okay. Now we move to the next one. Case 2. Case 2, if c is equal to minus pi. C is equal to minus pi, the interval becomes minus pi to plus pi, isn't it? So the very first one, a naught is equal to 1 by pi from minus pi to plus pi f of x dx. An is equal to 1 by pi integral minus pi to plus pi f of x cos nx dx. Bn is equal to 1 by pi from minus pi to plus pi f of x sin nx dx. So there are two cases. One is if c equal to 0. If c is equal to 0, the interval becomes 0 comma 2 pi a naught a n b n like this. So please remember, my dear students. Then if c is equal to minus pi, the interval becomes minus pi to plus pi. So a naught a n b n. So using the formula we can find the Fourier series f of x. And very important topic, the next one, Fourier series for odd function. So there are two classification in a function. One is odd function, another one even function. So if the function f of x is said to be odd, if f of minus x is equal to minus f of x, very important condition, please remember, simple. If f of minus x is equal to minus f of x, definitely the given function will be Fourier odd function. Okay, so here if it is odd, we should not find a naught and a n. Simply we can find bn only. Bn can be written as 2 by pi from 0 to pi f of x sin nx dx, isn't it? So the f of x contains only bn, isn't it? Please remember when the function is odd function. And the next one, Fourier series for even function. So very important. A function f of x is said to be even function if f of minus x is equal to plus f of x. Okay. Odd function f of minus x is equal to minus f of x. Even function f of minus x equal to plus f of x. Here we cannot find bn. So simply put bn equal to 0. We can find a naught and a n. A naught will be 2 by pi from 0 to pi f of x dx. An is equal to 2 by pi from 0 to pi f of x cos nx dx. So these are the formulas when we have odd function and even function. The next important thing, half range Fourier series. If a function f of x is defined over the range 0 to pi instead of 0 to 2 pi or minus pi to plus pi, so we have only 0 to pi, it is called a half range series. It can be expanded in a series, sine terms only or cosine terms only. So, if the function is Fourier, half-range Fourier series, either it can be extended up to sine series or cosine series, isn't it? Okay, now half-range sine series. Half-range sine series become f of x is equal to summation n is equal to 1 to infinity bn sin nx, where bn equal to 2 by pi integral 0 to pi f of x sin nx dx, isn't it? So this is called a half-range sine series. What about half-range cosine series? So the term f of x will be two terms, a naught by 2 plus summation n is equal to 1 to infinity a n cos nx, where a naught equal to 2 by pi 0 to pi f of x dx and a n is equal to 2 by pi 0 to pi f of x cos nx dx. So thank you, my dear students. So if you have any doubt, put it in the chat box. Okay, thank you.